I'll teach you current electricity. Right, my dear? So everyone, attention here only in the class itself. Okay, yes, beta. Okay, fine. So now, student, I'm going to start your class here as usual. So, what student I said here? What's the topic, my dear? That is student chapter's name, current electricity. What, my dear? This is current electric, current electricity. Right? Okay. So, students in current electricity, what? This now, student, I'm going to discuss here. I'll go with it in slow. Right? So first student, I wanted to tell student everyone what is the current. What, my dear? What is current? So student, mathematically you can write current is nothing but it is what student represented by I, and current you can write student, this is what rate of flow of charge. What student? Rate of flow of charge. What, my dear? Rate of flow of charge. Or students, we can say I is equals to, in another definition, student, flow of electron. What, my dear? Flow of electron per unit time. What is flow of electron per unit time? So students, this is the definition of, you can say, current electricity. Okay, now students, have a look at basic point as I said. So students, what is the SI unit of current? This is what, my dear? Ampere. This is what, my dear? Ampere. Students, you can also write here ampere. Ampere is equals to, this is what, students? Coulomb per second beta, right? Okay. After students, I want you to clear because there is beta. What is student? What is uh the CGS unit of current? Student, CGS unit of current, right? So maybe this is new for everyone, which is equals to bivolt. What, my dear? Celsius unit of current is what, my dear? This is nothing but we can say basically bivolt. Okay, fine. Now, students, I can say because you can also write here. This is 1 ampere. What, my dear? You can write, student. This is 1 ampere. One student ampere, which is equals to 10 volt. Students, 1 ampere, which is equals to 10 volt. Now, students, mean point here. Current belongs to quantity, scalar. Students, you can say this is current, beta G belongs to quantity, scalar. What beta? Current belongs to quantity, scalar. Right, which is okay. After students, just ignore my in relative data. I can also say current belongs to quantities tensor, but tensor not mentioned in our series J syllabus. So student current, what we have to consider, current belongs to quantity scalar media. Okay, fine. So you can understand here, which I said, current quantity which are, so this is what, you can take beta example. Now, current beta coming from this side few months, you can say beta, and finally going like this side. So you can take which as this is what, basically 10 ampere. This is what, 5 ampere. 10 minus 5. What you can write, my dear? This is a 5 ampere. Now, students, next question here. Beta, you can take beta like this. A few amount coming from this side, student, and going from this side. So you can take beta. This is what, 10 ampere. This is what, 2 ampere. Yes, both you can see conducting wire at an angle 90 degree. So no need to beta apply, I can say vectors law of summation, right? Simply beta 10 minus 2. What you can write here? This is what, 8 ampere. This is what, my dear? You can write simply, this is basically 8 ampere. This is basically beta, you can say this is what, 8 ampere. Okay. Yes, beta. Take snapshot everyone. Okay, fine. I hope already this would have taken. Now, बच्चा जी, next point here. I have to discuss. Yes, beta. Now, student, this I'm going to just I can say discuss in detail current electricity, right, my dear? Okay, so we can say for this condition, beta. Let us this is conducting wire. This is what, my dear, conducting wire, right? So in conducting wire, beta, no, there is no source at all. Student, there is no source at all. So this is the electron. This will spin for understanding. I'm arranging in a sequence all the electron, but students, in reality, this is not possible. In reality, beta, this is not possible, right? Okay, this understanding is I have taken. Now, beta, so you know what my question? My question goes to everyone. If any conductor, if any conductor which is not connected to external source of battery, so you have to comment. uh, inside the conductor, electron is in motion or not? Student, again, I'm repeating my question. What I'm telling student, inside the conductor, this conductor, you know, this there is no external source. So if there is no any external source among the conductor, so my question to everyone, beta, without connecting any source, we can say across the conductor, electron is in motion or rest. So now, beta, I'm telling you your answer, right? Students, if there is beta conductor, which is what? Uh, I can say along the conductor, there is no external source. So beta, electron is in motion inside. What, student? Electron is in motion inside the cylinder, but 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 not able to transfer its own energy because because conductor is not connected. Conductor, no, battery, battery. Student, battery is not connected across the conductor. So this is student, maybe you can think, sir, if there is no source, so inside the conductor electron is at rest. No, beta, not at all. This is not true. This is not true, my dear. Right? So keep in mind this point with separately. Okay. Beta, after this here, just beta, I'll discuss here more point. If conductor, beta, this is which I said, conductor across the conductor there is your battery. Now, students, next point. If conductor, if conductor is connected across the source, across the source. If conductor is connected across the source, then beta, what you can analyze the situation. Now, students, for this condition, let us suppose I'm considering a conductor. Student, I'm considering a conductor, right? So, student, inside the conductor, there is electron, there is electron, right? And student, across the conductor, there is one battery. So V is what beta is? Battery EMF, or you can say potential uh, of the battery. Now, students, here I'm considering L is what, my dear? L is the length of conductor, right, beta? Okay. So, student, I hope all of you remember this basic point. Electric field direction is opposite to what beta, you can say motion of electron. Beta, listen carefully what I'm telling you. Electric field direction is opposite to direction of motion of electron. Okay, now beta. So this is beta. You can see lower terminal batteries. Will beta. I'll just discuss very soon. I can say concept on battery beta. So this is what lower higher terminal of battery. This is lower terminal of battery, my dear. So here I'm considering this is lower terminal of battery. So this is zero. This is zero beta G. Now this is students. You can say potential V. So this is what potential V. So you can see across the conductor, there is what V volt of potential difference. What, my dear, you can say V volt of potential difference, right? So here you can see, so this is what basically direction of motion of electron. This is what beta direction of motion of electron. Now, students, you can see over here, this is what direction of electric field. This is what, my dear, direction of electric field. As I said here, motion of electron is opposite to what direction of electric field, my dear. Okay, fine. Student, this is V and this is what? Zero. So I hope it here I'm going to use a student relation between electric field and potential drop. Electron low to high potential and current opposite. Good, beta. God bless you, dear. I'm very happy to see, my dear. Okay, so here is what I'm going to use here. This result. So this is, I hope beta, all of you remember electric field which is equals to V upon L. Or beta, you can say in differential form, dV upon dx. This is what, my dear, dV upon dx, right? So, beta, just electric field and current both are opposite to motion of electron. Students, keep in mind, beta, this is the point. Yes, beta, G. You can say always electric student, electric field and current both are opposite to beta, opposite to direction of motion of an beta C electron. Okay, fine. And now, Bachaji, this beta. There are many things here which I wanted to discuss beta for numerical, right beta? So you can say for student numerical. Okay, what beta is? So, because there is one beta terminology which is used by G multiple time in the questions. So what is this, my dear? You can take this is what beta. This is the source. Now beta. So this is electron student. This is the direction of motion of electron, and this is what current bacha. So n is what? This is the point bacha. N is what? And beta is number of free charge carrier. Number of student free number of free charge beta number of free charge carrier depth velocity number of free electron number of free charge carrier beta very good Vichaji. I'll discuss beta depth velocity very soon. Number of free charge carrier beta what per unit volume bacha. So you can also beta represent here how the motion of electron my dear. Yes beta. Uh, beta, as because how we can represent. So which is this is what direction of it. This is we can say charge particle. So the charge particle what fill a force. F is equals to what QE. So this is what beta direction of force here because this is what direction of electric field beta G. And this is what beta I can say direction of beta G. We can say motion of electron, right? Beta, there is points there which I'll discuss very soon. Before that, I wanted to discuss basic one beta, little beta, basic one. I can say correct bacha F is equals to Q beta. In this class, student, you are yes beta. There is basic point. Battery is student source of energy. Battery is what may be a source of energy, right? Next one beta. You can write battery is a storage device. Battery is a storage device. Right, beta? Charge transfer energy. Keep in your mind that is all. Basic point display. I'm not skipping any bit point with you. So this is what my dear. Charge transfer. Charge transfer. Sir, keep questions rather in theory. Okay, just beta. Within 5 minutes, beta. I'll keep questions, beta. Beta, this question literally designed beta for advanced only. Just beta 5 minutes. I'm giving you better questions. I also believe beta. I can say in questions more here. Right, energy. If conductor is not connected through the source, then beta, what you can say? Displacement is zero. How it's it? Let us suppose beta, because already I have taken here. This is what I can say conductor, which is what connected to source. Okay. So here is student, I can say if there is no conductor, you can see beta this diagram, right? So this diagram beta, there is no source at all. So you can see beta, what is net displacement? It's what zero. This is what my D is zero. But beta here, this is what conductor connected through source. Students, if any conductor beta connected through source, beta for this condition, what you can say net displacement not is equals to zero. What beta? Net displacement not equals to zero. You can take beta consideration. Yes, beta. I can say bacha, this is the point, right now. Okay, this is what our bacha party. So you can find bacha party over here. No, this is what we average. Drift velocity, nothing but that. This is what we beta velocity average here. So this is what you can say, bacha, this R upon T, bacha. So this is, you can write drift velocity. This is what, my dear, drift velocity. This is what, my dear, drift velocity. Okay. Random motion of charged particle. Due to this, we have talked about average velocity. Because, oh, bacha, inside the conductor, there is what? A random motion of charged particle. So here we have to talk about only what? Average velocity. So with the average velocity is nothing there. This is what, my dear, drift velocity. So this is what we can say. This is displacement upon time. Displacement beta what I can see time. Now beta again here I want to derive the result as already you said beta. So I can see beta this is point beta. I'll write here directly. This is what, my dear, a derivation of I. Or you can say derivation of current relation with beta, this is the drift velocity. So simply beta, you can write here I is equals to N E A V D. I is equals to what beta? N E A V D. Where N is what? Number of free charge carrier per unit volume. A is charge, A is area cross section, and V D is what? Drift velocity. Okay. Now it's a drift velocity is the what? Average velocity of that particle. Such an electron attains such an electron attains in a material due to what? Electric field. Due to what which body? Electric field. So straight forward I'm writing a relation for drift velocity. This is beta Q E by M into tau. Beta this result beta you can get from what? Equation of motion first. Or beta what you can say for beta is kinematics, right? Beta there is one question here because you are demanding beta is the question. So now here I'm going to give you question beta about it. Beta I can say this is thing beta. This question asked by J beta multiple times. Not a single time beta, multiple times. Students, we can say as example for student for an beta unsymmetrical system for an beta what unsymmetrical conductor system like that beta. Comment on current. Student comment on beta G current. Okay, so we can take beta consideration like this. Yes, beta. Just tell me here, what is the value of current? I don't have. V is equals to QE by M and I is equals to uh, what you wrote, my dear. I didn't get your last point. Okay, so it what's this keep note mind bacha. For unsymmetrical conductor, bacha, I is equals to bacha, sir, integration. Okay, okay. I beta you can say what remains the same. I beta what you can say remains same, right, bacha? Why? Because bacha, you can take example of your if you did gardening at your home. If you want to put if you want you, if you wish to throw the water, I can say long length of the wire, or I can say tube. So for that condition, what you have to trace the what I can say uh, front part of the tube, right? So water finally what where you want to wish to go, but finally falling over there only. So this is what that's why what you can say there is different velocity VT1. This is what different velocity my dear, but this is what I remains same but separate. I remains what beta you can say remains same only. Okay, so beta already I said the formula here. Just let's beta move. I can see beta for little formula. I want you to see beta party. I want you to see beta. So this is already I said I is equals to N E A 3D beta. Then beta tell me a resistance formula. R is equals to what beta party? Tell me ML upon beta N E square tau into A. Then beta the resistivity R rho. This is M upon what beta? n e square tau. N e square tau. Now, with buddy, there is one more relation here. You can also sometimes we are using, that is R is equals to rho L by A. This is what, my dear, R is equals to rho L by A. So these are the basic formula which I just keep in mind. But I can just move down here. Mobility of charge carrier. This is what which says here. Mobility of charge carrier. Beta, can you tell me the answer, beta, for mobility of charge carrier here? Student, can you answer me with the mobility of charge carrier? Tell what's about it. This is what mu here. It is a beta ratio of drift velocity per unit electric field. What was about it? Drift velocity. Okay, conductivity beta. Yes, beta. You can see beta sigma conductivity. Yes, beta. It's a good question here. DUCITI. Beta is the conductivity. This is what, my dear, sigma. Sigma is equals to 1 upon rho. Sigma is equals to what, beta party? 1 upon rho. Okay. Beta, one more thing, beta party. I can say beta. One. But beta, first I'll give my dear entire formulas. Means I can say. Then I'll start with a numerical here. Will help you a lot. Right. So beta, one more formula. This is what, my dear. I can say current density. This is what, my dear, current density. J is equals to what? You can say sigma into A. J beta, you can say sigma into A. So these are the beta I can see finally formula here, which I gave you. Now beta, I can start the numerical only. Now beta, I can start the numerical only, beta. Okay. So beta, this is the first question here. This is the first question. Let us suppose you can take beta for any consideration. Beta, this is the main question, dear. J is equals to I by A. Yes, beta. You can also say beta. Yes, beta. You can say beta. J is equals to current per unit area beta body. So beta, let us suppose I'm considering beta I as a function of time t. Uh, then beta, you can say I as a beta function of time t beta 4 plus 2t. Beta, what I can see 4 plus 2t. Bacha ji, here find the charge. So now just I'm telling bacha, find student, find charge at t is equals to 2 seconds to t is equals to 6 seconds. Right, bacha ji? Okay. Tell me the answer here. Beta, after that, bacha, I'll solve. Yes, beta, I can also say here, I is equals to j into a. You can see, bacha. Tell beta the answer of this question here, then I'll solve these questions. Sir, integration and put limit. Okay, fine. Yes, beta, correct. You correct, my dear. So in beta, I can say solution here. Beta, I'll write it. I can step by step. Step one, bacha. I is what? 4 plus 2t. I, which I can write here. I hope you remember. dq plus dt बच्चा. So dq बच्चा जी 4 plus 2t into dt बच्चा. Just open the bracket here. So dq is equals to 4 into dt plus 2 into dt बच्चा. Limit apply beta. 0 to initial q बच्चा. And this is what? 2 to 6. 2 to 6 बच्चा. So this is, you can say बच्चा q 4t बच्चा जी. Limit beta 2 to, sorry, 2 to 6 plus 2t square by 2 into beta 2 to 6 here. 2 to 6 beta t. You can see beta these two cancel here. So q is equals to beta 4 into 6 minus 2 beta t plus students t square here. You can see 6 square minus beta t 2 square. So this is what 4 for the beta 16 plus beta 6 36. 36 minus beta 4. This is what 32. So you will get beta q is equals to beta g 48 coulomb. I hope you got same answer. Okay, very good, Bacha. Very happy to see Beta. What's your name, Bacha? And from where are you? From where are you, my dear? Yes, Vacha. So these kind of questions here. Uh, yes, sir. It's but you know, Vacha, I can't imagine. But they ask already this question, Vacha. Anywhere you can watch better video, right? Uh, Student, I'll upload this video as it is. Student, I'll upload this video, Vacha ji, as it is on YouTube, right? Okay. Now, Vacha, you know, there are standard numerical of resistance here to find resistance of the following, right, beta? So this is beta. This I wanted to do, Vacha. This is student first question. Do beta quickly here. I also want to do beta only numerical here. Yes. You didn't tell beta your name and from where are you watching? Sir, I am say, yes, looking your according to beta your beta reply, it's looking bacha your GS parent. So bacha, this I wanted to know from where are you watching this video and what's your name? Okay. Now bacha, you can take beta. This is what I'm considering my dear. This is a cuboid. This is what student cuboid, right? Yes, beta. This is you can say A, B, and C. You can take here. This is beta A. This is B. This is C. This is A. This is B. This is C. Okay. Now, beta here you have to find here. This is what you can see. Beta X. This is by. This is it. Beta find resistance. Find resistance. Beta Z along X by and Z along. Sir from Mumbai and my name is Aniket. Yesterday someone joined also by same name. But I can say Aniket from maybe someone joined here last 2 to 3 days also. Okay, beta. Now, beta, answer me, Aniket, beta. Very good, yaar. I'm very happy to see dear, your dedication. Yes, kind of boys here. You are supporting online education, beta. It's very good, beta. It's very good, beta. How you are replying each and every question, my dear. Okay. So, beta, I'm just writing, beta. I'm calling beta R1 is nothing here. It's RX. Just now, beta, we finished the formula here. Rho L by A. Beta, you know, beta resistance depends on what? Beta temperature, material, direction of flow of current, bacha, body, dimensions of the body as well. So here, bacha, what you can see? Length of the directions of flow of current, bacha. So rho L. L is what? A. And beta, what's the area? This is what? BC. So this is area, bacha. R2 beta, you can see R by beta remains same here. Rho and L is what? Along the length of direction of flow of current, bacha. So this is what? You can say, bacha, party B. Upon beta G, you can say AC. Beta, this is what R3 are. So this is RG bacha. Along beta, the L is what? Along the length of directions of flow of current bacha. Rho C upon what? You can say AB. Beta, what you can say? This is what? AB. Okay, beta. I hope you got same answer, no? I hope beta you got same answer, bacha ji. Okay. Now beta, the next question. This one there is what? I can say concentric cylinder. There is what made you? I can say concentric cylinder. Yes, beta. Yes, beta. If you ask parents, so I can say you already got to know question. What is the question? Yes, beta. Okay, good. Good, beta. So now, students, I can say this is what media directions of flow of current, which is equals to I. Beta, what which is equals to I. Beta, I can take beta. You can take my dear. R1 is what? Radius beta. Of beta, what you can say? Beta smaller cylinder. R2 beta is what you can say? Beta R1 beta radius beta smaller cylinder. R2 beta is what you can say? This is what radius beta is for beta. You can say larger cylinder. Beta here we wish to find resistance. Find beta is resistance. Right. So beta what is formula? Beta here can apply simply here. Why? Because I beta remains constant. I beta what you can say remains my dear constant. So simply, bacha, there is no need to worry or to write. And A is what you can see, beta. This is area of cross section, beta. This front part only, right, bacha? So here you can see R is equal to my dear rho L. L is what, beta? You can take length of cylinder. Upon bacha party pi into bacha this is R2 square minus R1 square. This is beta. You can see R. The resistance of what I can see this kind of arrangement. Now let's I'm going to change here. Next question will be XA. Beta I can say Aniket R2 minus R1. R square minus beta this is what? Area here. So what's the area of cross section? This is circle only dear. This is beta is only circle. You can beta think like that, ne beta. This is I can say beta circle only. Smaller circle beta and bigger circle. You can beta think like that. Because this is beta, you're looking from this side here. You will see beta from here, bacha. So this is the actual diagram beta. You will get here for top view. This is R1, my dear. And this is what you can see R2. This is what beta you can say R2. I hope you got it. Student, is your doubt clear? Okay. Uh, good, my dear Aniket. Now we can have a look at the next question here. Beta, in this question, my dear, there is little change. Beta, in this question, beta, this is what little change. What was about it? Yes. Beta, again, this is a concentric cylinder. This is what made here concentric cylinder, right? Okay. And here, beta, I'm going to change basically what you can say directions of flow of current. What was the directions of flow of current, right? So beta, you can say here, this is different directions of flow of current. This is what my dear direction of flow of current. You can take beta as usual here. This is R1 beta G. This is R2. Beta find R equivalent, my dear. Student find R equivalent, which student you can take beta as usual. L is what? Length of a cylinder. L is what beta G? Length of cylinder. But you know, Aniket beta, here you can't write. Aniket beta, you can't apply the resistance formula directly. Why? Because beta again make diagram bacha of this cross section area top view. Student, you will make diagram beta for cross beta questions remains same. First beta, you wanted to complete the questions. Find resistance. What was the find resistance, right? So this is what media R1. Now student, this is what R2. This is what R2. So here students, you can say this is R1. This is R1 beta, and this is what R2. So beta, the area is changing beta. So this condition we have to apply concept of integration. Yes, sir. Now this is time we'll take curved surface area. Yes, very good. Very good beta. Very good Aniket beta. So now beta, yes, we have to move beta. R, student, you have to move R and beta G, take element DR. Student, you have to move R and beta G, take element DR. Yes, beta. This kind of concept doesn't apply. We have to move R and take element dr, right? So this is beta. This beta already are elemental resistance only for this ring only also. So what is this beta? Formula beta I'll use same only. R is equal to L by A. This is rho beta and L is what? You can say dr. Upon beta party, this is cylinder area beta 2 pi RL. What which are 2 pi RL. So beta, this is expression for I can say a small element. But beta, we wish to find entire resistance beta party. If you wish to find beta entire resistance, then you have to use a tool of integration. If you have many small pieces, but if you want to find just a combination of entire pieces, beta for such condition, you can apply what integration principle which so this is what beta integration of dr rho which this is what you can see 2 pi l integration beta this is dr upon r limit beta what we can apply this is r1 to r2 so this is beta you can see r equivalent which party this is beta ji rho upon 2 pi L. This is what beta ln of beta R2 upon R1. So this is what beta I can say R equivalent. This is what my dear you can say basically R equivalent beta. So this is beta I can say resistance. This is what beta I can say resistance beta for this kind of element. Okay. For I hope you finish with that. Of length diya. Very good. Very good, Aniket Bacha. Very good, Aniket Bacha. Okay, beta. Now, student, I'm giving you beta one more numerical based on this. So this is what questions remain same, bacha. Questions beta remain same. Beta, I can say, let us suppose there is what beta I can say conducting concentric spherical cell. What, my dear? Concentric conducting beta spherical cell. Right. You can take bacha ji. This is students resistance. Yeah, means radius is R1 is not resistance. Beta, I can say for largest sphere, this is what you can say beta R2. There are two beta concentric conducting sphere. Inner sphere beta radius R1. Outer you can see this is what R2. Questions remain same, bacha. Find resistance. Find bacha ji resistance here. Figure shown. What student find resistance bacha party and figure shown. Okay. So beta, how can we do further here? Again, bacha part. You can apply bacha. You have to move R. Student, you have to move R and beta, you have to move R. Beta, I'll do here, bacha. You have to move R and beta take element dr. Student, you have to move R and beta what you can say take element dr. You have to move R beta and take element dr. Okay, so beta right expression beta for elemental resistance. Dr is what? Rho into L. What's the area of a sphere here? 4 pi r square. 4 pi beta r square. Simple beta. Just integrate both sides. So this is here rho upon beta z 4 pi. This is dr upon r square. Limit beta z what you can say r1 to r2. This is what you can say r initials to r final layer. So you can write beta this is r only rho upon 4 pi. This is what my dear minus 1 upon r. This is r2 and this is what r1. So beta what's the resistance here? Rho by 4 pi 1 upon r1 minus 1 upon r2. Beta further this it depends on option which how they plan the option. Integration as secret. Okay, what's secret Aniket? You didn't tell. What's the secret Aniket? Which okay. Now, Jaji, move here. I can say next question. Beta JEE Advanced 20 beta G 17 student. Now I'm going to solve those questions which came in what JEE Advanced beta G 2017. Yes, beta. Okay, good, 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 my dear. Very good. So beta, this questions here came in student. I can say this is JEE Advanced 2017. Right, it's a very standard numerical Vichaji. What is it? You can take a frustum problem. This is what, my dear? Custom problem, right? Okay. Doing custom problem, beta, don't be frustrated, right? You can take beta. Huh, yes, Aniket. Doing custom problem, beta, don't be frustrated. Custom, of course. Yes, beta. This is a question, yeah. Yes, beta. Hmm. Yes, Aniket. Beta, you can take beta. This is the custom problem, right? Beta, you can take, my dear. This is L. L is what, beta? The length, right? Uh, Here, beta, I can suppose to take like directions of flow of current. Student, you can take, my dear. This is R1. This is R2. This is R1. This is what R2, beta. Beta, find your questions remain same. Find R equivalent. And find R equivalent. Yes, beta. Do you want to try beta? Uh, okay. Uh, Now, beta, see. I'm doing beta. You do also. Now, beta, what's the beta basic point? We have to move x. You have to move x. You have to move x and take element dx. This is beta. I can say primary is stay unthinking for this question. Student, you have to move x and take element dx. So beta dx is what? Beta element what you have taken. This is nothing but beta. It's a disk. You have to move x and beta is take element dx. This is what you can see beta is disk. This is what beta you can see disk, right? So disk beta radius is compulsory beta, right? So student, here I'm considering r is what beta radius of disk. R is what beta the radius of disk. This is x beta. Now I'm calling my dear. This is what y, not y. This is r only. This is what Vitaji are only, right? So Vitaji for this condition here. First, I wanted to write beta what is the elemental expression of resistance, which is equals to student dr. Student, which is equals to dr. So what is dr, my dear? Rho into dx upon Vitaji pi r square. This is student resistance which I wrote only for element only, right? R1 and beta, what you can see R2. Okay, now with Chaji, just beta, because now you can see, sir, we have a single equation. We have a two relation, X and R. So we have to replace any of this, any one of this. So now beta, you can say, this is X beta G, and this is what you can say R. This is what you can say, bacha R. Here beta, you can think like that, bacha. You can better just think better like similar. This is X and this is what? Y. So beta y is equals to mx plus c. So beta I'll write here. R is equals to slope. Slope is what beta? Beta here I am just beta taking some consideration beta. R1 is equals to A and beta is R2 is equals to B. So here beta I'll use your R means equation. This is y is equals to mx plus c. So beta what's the slope here? This minus this beta. So m is equals to b minus a upon L into x plus c is what beta remains a only. C is what beta? This is what intercept you are. So this is what remains a only. Now beta, we got a relation. Just beta differentiate both sides. So beta once you will differentiate, so r becomes what my dear? dr. This is b minus a upon L. into beta dx. Now beta we have written there. Beta this dx value beta we got from here. So this dx value beta we can just put over there. So dx value we can write here. Dx is equals to dr into L upon b minus a. Dx is equals to dr into L upon beta what we can say b minus a. This is what I bacha dx value beta I'll feed in this equation bacha. So this is my dear dr is equals to rho bacha party upon pi r square. But keep not mind here. Already beta we wrote expression I can say for resistance what small element. Good question. Ah yes. Here beta will get everything. But I know that is a student Aniket. No, what I have a target. But I have a target Aniket. Yes, I'm telling because this is for everyone. But till means I started Saturday. Saturday to next Sunday. Beta I'll try to complete entire J advanced PYQs for electrodynamics entire J advanced PYQs, beta. I'll try, beta. The advanced PYQs for I can say main as well as advanced, so that your maximum can get benefit from physics point channel, which so rho beta pi r square. ds we can beta right over there. This is L which G. You can see this is dr upon beta b minus a. Now beta just integrate your both side. Beta just integrate both side here. Now, beta, just take snapshot, my dear. I wanted to turn the page. Okay, I hope you've taken my dear. Or you're also solving there. No need to snapshot for you. You are a good candidate. So this is what beta we got here. dr is equals to what beta party? Yes, beta. You can take L into r beta outside. L into r. Upon which party you can see pi r square. Integration beta. Integration beta dr upon d minus a. L into rho L into rho upon beta dr upon beta b minus a upon which party b minus a. Very nice here. Beta apply limit here. A to b beta. Keep to the variable here and constant separate. So this is dr my dear. This is what my dear? Dear S correct. S secret. Secret. Now beta I can say L rho L upon what which this is pi it has the pi into b minus a. This is a to b bacha dr upon r square. But I know this is very favorite yeah, and I can see integration. So this is what bacha dx upon x square minus 1 upon x. So dr beta becomes r only. Rho L upon beta I times b minus a into beta minus 1 by r limit beta a to b beta minus beta adjust each other. So you can say beta rho L upon pi times b minus a into beta 1 upon a minus 1 upon b beta. Take LCM beta body. So r you can take beta. This is rho L upon pi into beta b minus a b minus a upon beta is what we can say ab. I can say b minus a cancel. This is rho L upon pi AB. You know, beta, what they ask, beta? They ask beta question in terms of beta integer. Beta, they ask this question, beta ji. They asked in terms of integer, beta, something here. They multiply by n like that. So let us suppose if there is n. So what's the answer, beta? N is equals to 1. But my dear, n is equals to 1, beta. So these are the points, beta, which you can keep in your mind. Okay, now beta, I'll discuss here little theory, bacha. Okay, then beta, again I'll do my question to my Aniket. Okay, so bacha, see, you can say, bacha, okay. This is what bacha? This is variable temperature, uh, resistance, varies with temperature, beta. Beta, there are two segments here. Beta, first you need to discuss, means I'll discuss beta, conductor, and this is student for, you can say beta ji, for semiconductor, right? So beta, for conductor here. Now, student, if we will increase temperature, N is what? Number of free charge carrier. So, but there, no, this is remains same. There is no change, bacha. This is remains the same, bacha ji. This is what, my dear, remains the same only. But beta, if you will increase temperature, bacha, if you will increase temperature, then beta, your relaxation time got, because no beta, randomness of molecule beta increases. So this is what beta I can say. Relaxation time beta what got decreases. Student, if you will increase temperature, then resistance as well as beta resistivity both will increase. Both will increase. Simple beta. You can apply the formula here. R is equals to what beta? Just now I said ml upon n e square tau into a. Yes, it's this factor that I can apply. You will get an entire explanation which I wrote with somebody. Normal class beta, you can say minimum 10 to 5 minutes just discuss in detail these all points. But here, yeah, no, my intention to just discuss detailed more about numerical bacha. Rho is what bacha you can say. This is m. Upon bacha, what you can say? N a square tau. This is what formula for rho. Now, beta, I'm going to discuss about I can see what beta semiconductor. Yeah. So here, beta, it will increase temperature. Yeah. What semiconductor? Few electrons are movable, few electrons are fixed. Few are ready to move, beta, and few are what movable, beta. So if temperature increases, so what beta you can see? What beta you can see? This is beta, and also increases. And beta, what you can see also increases. Now, beta, if you are increasing temperature, beta, so what? As usual, you can see relaxation time got decreases. Student, if you are increasing temperature, then beta resistance also decreases and beta resistivity also decreases. Beta is what? Resistivity also decreases. So these are the beta basic point. Keep in your mind, beta party. It's a theory question here. Beta already I gave. Right, beta party. Next here, beta there is a relation of relation beta party. There, student, I can see a relation beta party. Right. So beta for this condition here, I wanted to discuss beta, right? Uh, this is beta. I can say R final. Student, this is what dear? R final. So that's it equals to beta. I can say this is R initial plus R initial alpha delta D. But I know 99.99 cases they will ask this question, this formula. But beta, there is 1% possibility, my dear. Student, there is 1% possibility. They can ask it about, let us suppose, you can apply this formula if alpha is constant. Student, you can apply this formula. Student, you can apply this formula for which case, if what you can say, alpha is constant. Student, if your alpha is not constant, then beta, you can't apply this formula. Beta, you can't apply this formula. For this condition, what you can say, bacha party? R final is equals to R initial plus R initial integration of alpha into dt. Here, beta, they will give you alpha as a function of temperature. Student, here they will give you bacha alpha is what function of temperature. Yes, bacha. Now, beta, I will look at next question. Beta, just a few points here I wanted to discuss about beta. I can say alpha. Alpha beta, you can see this is what? Positive for conductor. Alpha beta, positive for what, my dear? This is for conductor. Alpha beta is the positive for conductor, right, beta? Alpha beta is the positive for conductor. Beta is the alpha. You can say, beta, not you can say it's a true, beta. Alpha is equals to negative for what, beta? For semi conductor. Alpha beta what? Beta you can say for semiconductor. Okay. Now, bacha buddy, have a look at the next. So here, bacha, you can just do one question here based on this concept. Uh, okay, there are two peoples. One is Aniket. One is more people. Aniket beta. One is beta. One more. Aniket beta. Is this one to you? Yes, beta. Question beta Aniket. Find out relation between student. Find out relation between beta जी row one, row two, beta alpha one, and alpha two, such that student such that temperature, or you can say the total resistance of system is independent of temperature, such that student total resistance of the total resistance of the system is beta G independent of temperature. Right, but this is the question there. Remaining beta, just I'm going to show you beta as a diagram. So beta, what's the diagram here? You can see find out relation between row 1 and row 2. Beta, I know there are two. I can say beta. Beta, there are what? Two identical rod. This is the question beta. There are student two identical rod. So you can say beta. This is also a beta, and both are connected in this fashion. Both are connected beta end to end, right? So this is what beta. This is remains L. This is what beta remains L only. Beta, this is, you can say row 1 and beta alpha 1. This is row 2 and what you can say beta party alpha 2. Row 2 beta, what you can say this is what alpha 2. Okay, already beta mentioned the question that independent of what beta the temperature. So beta you can write here resistance rho L by A. Beta both are in series beta party. This is the question here. Now beta I'm going to solve this question. Now beta I'm going to solve this question, my dear. Right. So you can see bacha, this is rho 1 L by A plus beta C rho 2 L by A beta initially. Now beta I'm going to write I can say for combination here or you can say after rising temperature. After rising beta what I can say temperature. This is what beta rho 1 L upon A beta 1 plus alpha 1 delta T plus beta C rho 2 L by A 1 plus alpha 2 delta t. Right, bacha ji? So this is you can beta write here further. Then bacha, just beta, just open the bracket, beta right side. So rho 1 L by A plus beta rho 2 L by A is equals to rho 1 L by A plus beta rho 1 L by A into beta alpha 1 delta t plus बच्चा है जी रो टू एल बाई ए प्लस रो टू एल बाई ए into alpha to beta and what you can say delta t. Okay, what you can say my dear delta t. Okay, बच्चा जी you can say this rho 1 L1 beta rho 1 L1 beta जी rho 2 L2 rho 2 L2 beta finish. Beta जी what you can say finish beta just equate beta these two. So what you can write rho 1 L1 alpha 1 upon beta A into beta delta t is equals to which about minus rho 2 L2 alpha 2 into beta delta t upon beta C A only. Basically, you can see what's delta t and A beta cancel each other. So beta, what will you get which about finally? L1 L2 beta remains the bacha. So again, you can say, sir, this L1 L2 also finished. So what you can write, my dear? Rho 1 alpha 1 is equals to beta d minus rho 2 alpha 2. Rho 1 alpha 1 is equals to what which party? Minus rho 2 alpha 2. Right, which party? So this is the condition here. Okay, for this question, my dear. Aniket, Did you solve this question, Aniket beta? Okay, fine. Uh, now beta ji, just move your next question, bacha. Or I can say, concept here, I'll leave, right, beta? Just I'll do the questions more, bacha party. I'll do the question more here. Okay. Now I can say, beta, KCL, KVL. I hope you know everyone, KCL and KVL. So beta, without wasting time, bacha, I'm going to do the question here for KCL, KVL. Right? Yes, beta. I'm going to do your question based on what I can say KCL, KVL. Yes, beta ji. Or beta, I can say I do few basic question methodology based on this parameter also for mains question. Yes, beta. For do your few basic question of mains beta ji based on this. At least one questions they are required. Okay. I can say, beta, there is one result here which I wanted to see in the live stream classes because that is what format of resistance basically. But that is what I can say with a format of resistance here. This question literally with a very useful, my dear. That is this question which I can say literally with a very useful, my dear. Right. So what's the question here? Concept of resistance if wire is stretched. Students, this is concept of resistance if wire is stretched. If wire is what I can say stretched, right? Okay, yeah, beta, this is highly important. The student J asked multiple times this question. 100% beta, you will get this question. There is no doubt at all. There is no doubt at all, beta. This is literally very useful concept, beta J. Right? So, beta, keep in your mind, my dear. Okay, you can take beta for consideration. As an example, you can understand. Let us suppose, student, you have what? Conducting wire. This is what, my dear? Conducting wire, right? You can say, bacha, this is what L. L is what length. Beta ji, rho is what resistivity. A is what area of cross section, right, bacha ji? Then students, now I'm going to stretch here. Let us suppose I'm going to beta what this. I wanted to do twice of is this initial length. Beta, you can think like that. Yes, beta, you can think like that. Student, now we can see initially same conducting wire. This is length is L beta. Now this is what you can see 12. Now beta, what you can see, this is what basically 12. So beta, just we have to comment here on area. Area beta initially A bacha. So what is the final area bacha party? So here you can write bacha. Simple here. Beta, volume remains constant. Student volume initial is equals to beta volume final here. Beta, what is volume initial? Area into length is equals to beta, I can say area final into beta L final here. So beta, what is area initial length beta? This is area into length remains constant which area final which let us suppose we don't know. Length final mentioned here. This is what 12. Now we can say beta L and L cancel. So student you can write here area final, which is nothing but beta what we can say area final which is equals to A by 2. Area final beta what we can say this is what basically A by 2. Okay, so beta let us suppose you can take beta consideration initially this wire resistance is what are beta initial beta wire resistance is what are as your carrier is not in UT go to college in school and no beta already I'm in college beta sis beta I'm in Narana college beta Narana Pure college. Yes, beta. Why you are thinking like that, my dear? I mean, I run off you call beta Bangalore. Yes, beta ji. So, beta, this is beta. This is I can say. I'm just. I wanted to spread my knowledge to everyone, beta. Because no, in Narayana Akash, I said already, I taught beta there. Student, already I taught in Akash, physics point. Now I'm in Narayana, Bangalore. Everywhere I'm teaching a student. But I wanted to spread myself, I wanted to share my knowledge for each and every candidate. So entire India can learn from me. Right, Vatsya? So that's how it I started here, I think, my channel and just taking live classes more. So beta, what is racing Vatsya party? This is, we can say Vatsya, a row into what? Row beta, means it's the nature of material Vatsya. L beta, L is what? You can say this is twice. And area Vatsya what? Area final is what? Beta A by 2. So this is what? Rho L by A into beta 4R. So what is the beta? Resistance final beta G? uh, beta G resistance final beta. This is what you can say 4 times of R. This is what may be 4 times of R. Okay. So beta, keep in your mind here. There is one more relation beta G. I can say based on this concept. Yes, beta. That is just very, very helpful here. I want you to write here, my dear. Right. So what's the result here? You know, beta, this is, you can say resistance. We can write rho L by A. What bacha? Rho L by A. Beta just beta to multiply divide. Beta just multiply divide by bacha, what I can say length and length. So beta R is equals to rho L square into beta A into L. Beta this is what you can say volume. So beta resistance you can say R rho L square upon V bacha. R is what my dear? Rho L square upon V bacha. So this is V is nothing but this is what beta is volume. It's beta literally a very very helpful bacha. I can see, bacha, this is the result. Bacha, resistance is equals to rho L square upon V. Beta, you will get your multiple questions based on this. Beta, this is literally highly important, highly recommendation for each and every J aspirants. Right, bacha party? I hope you got the question, bacha party. Yes, beta, I wanted to do a more question. That is a short trick, bacha. Literally, beta, it's a short trick. What's the question? A wire is stretched. A wire is stretched to increase its length by 1.5%. Find percentage in change. Student, find percentage change. Find percentage change in what is it? Length. That is find percentage change in length. Bacha. Right. So beta have a look here, my dear. It's again here. Kinds of good question. Bacha. Means I beta this question we can also do by method. But I'll do this question by short trick and within 10 or 15 seconds. Yes, beta ji. So what's the short trick here? Beta short trick is what bacha but a percentage change bacha. While first beta we remember. First we remember percentage change in beta ji resistance. This is what beta R final minus R initial upon R initial into 100%. Right. So beta, I can see what is the formula here. Beta, there is a formula beta to get a direct result over there. This is what this formula actually I'm giving you my dear student. I'm giving you this is the short trick. Literally beta, short trick will save your time beta a lot. Yes, beta. Time beta a lot here. So this is what percentage beta. You can see for resistance final beta. You can simply write beta L n square minus 1 into beta what you can say 100. Then beta how can you get it? N is what beta? You can say length final upon length initial. That's all. Beta. What is the beta see? N here n is what beta? What is the formula? Percentage change. But by short trick n square minus 1 into 100 beta. So n is what? You can say L final upon L, which is the initial, right, Bachaji? So now here, what's in the questions? A wire is stretched to increase its length. Increase. So initially you can take beta 1 meter. Initially beta you can take 1 year. So what's bacha? I can say increase bacha. This is what you can say 1 point what 15 upon bacha party. This is beta what? L initial beta remains L only. So beta this is what you can see bacha. You can write beta like this. L upon L. L cancel bacha. So this is 1.15 my dear. Beta I can say assist. God bless you beta for your I can say kind thinking about me bacha. I'm very happy to see beta your appreciation, your kind word beta. And bacha we got here. Beta feed bacha party here directly. Beta feed bacha you can say directly bacha, right? So R beta what you can get beta R final 1.15 bacha ji whole square minus 1 beta. So 1.15 beta what will get here? Tell me 2.25 minus 1 into beta is 100 here. So finally beta what you can see 125. So this is what student you can see R final. So it's short trick beta. It's literally very easy beta. Short trick beta I'll appreciate everywhere because it's literally very useful my dear. Okay. Then beta I wanted to discuss little about I can say battery. Beta I wanted to discuss about beta I can say little about the battery my dear. Right. So beta have a look beta party. Beta, what is beta? I can see on battery. We have a beta two kinds of battery. Student concept on beta. I can say battery, right? So beta for concept on battery here. Beta, just keep in mind how this is. Beta, this is higher potential, or you can say beta higher terminal beta party of the battery. This is what is the lower terminal of the battery. Let us suppose students you can take for consideration. There is what charge Q, my dear. Charge Q, my dear, is what you can see beta just moving like this. So beta here just you have to tell me what is the potential energy if this charge particle what crossing this V volt battery. So you can say potential energy which is equals to U. It's nothing but this is what beta you can write Q into V. This is what beta you can write Q into V, my dear. Okay, fine. So beta the how the things beta you can understand. Let us suppose you can beta think about the resistance. What is the works of these all things? That you can take it. V is what potential. R is beta what resistance. Because this is zero potential beta Z. This is zero potential. This is V. This is V. Right, Vacha? So what is the potential energy beta? That is what charge particle carrying from what crossing potential V volt battery. This is what QV. So who will I can say exhausted entire charge? That is nothing but you can say what's a what you can say entire energy what beta you can say taken by resistor what's a party only, right? Resistor what it is entire energy here. This is what my dear you can say this is basically connecting wire. Beta keep in mind keep in your mind student connecting wire resistance beta almost you can say what's a party what that is what zero. That is what my dear zero. Now, bacha, I can say battery. We have two kinds of battery, bacha. Ideal battery, beta, or you can say non-ideal battery. Beta ji, I can say for this is what my dear battery. Beta ji, we have two kinds of battery. This is what bacha you can say non-ideal battery, and this is you can say bacha ideal battery. Beta, what is difference is these two bacha? Beta, in ideal battery, bacha. In ideal battery, bacha, there is no internal resistance. Beta what? There is no internal resistance. Beta for non-ideal battery, bacha, S. This is beta differences. There is what, my dear? Internal resistance. There is what, my dear? Internal resistance. Right? Okay. Bacha ji, I wanted to explain here more point over there. This is electromotive force. So this is what, my dear? It's nothing but it's EMF here. So what is electromotive force? It is work done by battery. It is work done by battery to carry a what? Unit positive charge. To carry a what? Unit positive charge. From what was the party? Lower potentials to higher potential. What was that? Lower potentials to higher potential. So what I can write here, battery is what? Converting chemical energy into what was the party? Electrical energy beta. These are the basic point beta, which you can keep in your mind. Battery is what, my dear? Battery is what converting chemical energy into beta what you can say mechanical energy. So beta you can also write here EMF. Beta you can also write beta what is EMF? EMF beta you can also write this is work done per unit charge. You can write beta EMF is equals to work done. What was charge? Work done per unit charge. So beta, what is the unit here? Joule per coulomb, which is equals to nothing beta. You can say volt. This thing, beta, what you can say? Coulomb per beta. Work done beta what per unit charge. Yes, beta. Now, beta ji, I can say in circuit beta battery we have a two kinds of circuit, beta. Beta in battery beta we have a what? Two kinds of circuit, right? Okay, I can say beta discharging circuit or beta I can say what? Charging circuit. Okay, I'll discuss one by one. Yes, beta, I'll discuss one by one. So this is what, my dear? Discharging, discharging circuit. Yes, beta. This is what beta I can say discharging circuit. Okay. Beta, just let us suppose as a consideration, this is what EMF of the cell, which is connected to what beta? Internal resistance R, right? Okay. Now, students, just here, no, this entire setup is nothing but it's a what V volt battery. Entire setup is nothing but what we can say V volt battery. Let us suppose this would current started flowing from here. Current which has started what flowing from here, which this is nothing but you can say I. So this is what I, which you can take with any point. Let us suppose I'm considering my dear. This point is A and this point is B. This point is B. But the current always flowing from what I can say higher potentials to lower potential. So this is what I can say VA. So this is VA beta. Now you know beta on the register. On the register, it's a sign convention you can check according to direction of motion of current. So beta current what? This is the direction of motion of current. So you know current always flow from higher potentials to lower potential. So we can say this is plus, my dear, this is what minus. This is plus beta, this is what you can say minus beta. Keep in your mind, beta, but current always flow from what beta, but higher potentials to lower potential. This is what I'm explaining about discharging circuit. So this is beta, I can say higher potential, which is I have taken V, which is positive beta. Now you can say minus IR, plus to minus what beta? You can take minus plus to minus beta. What you will take? Minus beta beta. So beta, this is you can say minus IR beta. This is what IR. R beta, you can say internal resistance of the battery. IR beta beta. Plus beta, minus to plus. Then you can take plus. This is E beta. Minus beta, lower potential, minus VV, which is equals to 0. So here you can write which is this is VA minus VB is equal to what was about it? This is you can say minus E plus IR. Or beta you can also write this is VV minus VA is what was about it? E minus IR. Yes, beta. VV minus VA. What you can say E minus IR. Okay, let us see here. This I wanted to just apply this concept in a normal circuit. So students, you can take here for the condition. This is what beta resistance R, right? Which is connected to beta. I can say cell EMF is E, and this is what beta. You can say internal resistance R, right? So beta, this is R, bacha. This is R. This is what? E. This is what? E. Now, students, entire setup here already we discussed. What is this? Beta, you can say potential difference, or you can say this is basically battery. If beta they are in the question availing directly, student, if in the questions directly, if they are availing V, then there is no loss they are considering. But if they are availing with chapati, that is internal resistance, means what they are considering losses as well. They are considering losses as well with chapati. Okay, fine, Vacha. So, beta, what you can see, beta, further, my dear, over here, this is, beta, let us suppose you started motion from here only. So beta, you can also say, bacha, this is nothing but its entire system, beta, or entire setup. You can also call as a what? Source. Also call as a what, bacha party? You can say source. So beta, what is drop over there? Yeah? Already we found V is equals to E minus IR. V is equals to what, bacha? E minus IR. Beta, just here, beta current flow in this circuit till now, what you can see, beta potential difference across these two. You can see this entire setup and this resistance must should be equal. Beta for that condition, you can see what potential difference remains equal, drop equal on both of the, you can say, circuit element. This is beta what resistance, bacha, and this is what you can see battery. So beta just equate bacha, party these all things here. So you can say, bacha, V is equals to what, beta? We just calculated. Uh, V is equals to E, beta. What's the drop here? V is equals to E minus IR. Beta, just find here. Bacha ji, find I from here, bacha. I beta from here. So what is I, bacha? What you can write? I is equals to EMF beta upon R equivalent beta. These two are in resistance here, series. So you can say I is equals to E by R plus R, but I just fit the value over here, bacha. So you can say E bacha party minus R. I into I is what, bacha? E upon R plus R into beta what you can say R only. Beta this beta. Take LCM bacha R plus R. So you can write, my dear, V is equals to E into R plus R minus ER upon beta is R plus R. ER here beta cancel. So we can write here, bacha, this is E into capital R upon beta is R plus R. Beta, this is the potential difference, bacha, which you can keep in your mind across the what you can say register. Beta, what you can say across the beta. This is beta drop, which I found E into R by R plus R, bacha, what you can say potential drop across the register, bacha party. Okay, have a look, bacha. That is the next one. This is all about, I can say, discharging of circuit, bacha. Next, beta, have a look next. Charging circuit, beta ji. What my dear? This is next. Huh? Beta ji, charging circuit. Beta ji, you can say this is what charging circuit. Charging circuit. Right. Okay. Beta ji, for this condition, no, but this is, we can say, battery, but it's a large battery. Energy is more over here stored, right? Yes, beta. Now, beta, this battery is what? Let us suppose, take beta as an assumption. I'm going to connect beta. I can say old battery or small battery, right? So this is what, my dear, you can say E. This is what R beta, right? So current beta flowing like this. This is I. This is what, I can say I. Beta, this setup here already, what is this? What you can say? Circuit for charging. Beta, what you can say, circuit for charging, bacha. Or you can say also, battery acts as a load. Battery acts as a load. So you can tell, this is zero, this is zero. Then beta, you can say this is V, this is V. Now, party, this is condition here. Okay, Bacha, you can write, my dear. This is a bit, let us suppose, it's a big battery here. So this will allow to flow current in this direction, Bacha party. beta I can say beta for this one what allow to flow beta what current beta in this traditional beta party. So what you can say V minus E minus IR is equals to 0 बच्चा. Next बच्चा जी can write with the finally V is equals to beta जी E plus IR. V is equals to E plus IR. So beta this is not always true बच्चा. This is not always true बच्चा. You can keep in your mind V is equals to E plus IR. No beta. Both are true. E minus IR beta for discharging circuit. V is equals to E plus IR beta G for charging circuit. So keep in your mind these two differences my dear. Beta keep in your mind बच्चा what? These two differences बच्चा party. Okay. Next बच्चा I can say this is what? Short circuiting. What was Jeopardy? Next, I can say, my dear, this is short circuiting. What was the short circuiting here? So we can say the Jeopardy. Now, students, you can say like this. This is a resistor. Across beta resistor beta, I connected what? You can say a connecting wire. What was Jeopardy? Connecting wire. You can take with that. This is point A, this is point B. And this is what beta current IR. So we can say this is VA minus VB is equals to IR. So we can write, my dear, VA minus VB is equals to 0. VA is equals to VB. VA is equals to what bacha you can say? VB bacha. So these are the beta points which you can keep in your mind and highly important bacha party. So this is beta short circuiting. Now beta you can just also think beta short circuiting a battery. What my dear? You can also think bacha short circuiting student. This is short circuiting for a battery. Yes, beta. Short circuiting for what is that? We can say for battery, right? So taking with a think like that. This is a plane connecting by which or plane by you can say. Now this is a student connected through what? I can say EMF of cell is E and internal resistance is what was the party R. So this is E my dear, this is R. Now beta, let us suppose as assumption here. Because no bacha, everywhere. Because this is connecting by bacha. So 0, 0, 0. Right bacha. Let us suppose beta this point also you can take as a consideration point A and this is what beta point B. So we can write bacha VA minus VB is equals to 0. So what bacha you can say VA is equals to VB. VA beta what is equals to VB and which is equals to 0, which is equals to 0. Now which I can beta just apply beta one time. I can say potential difference for entire circuit. So this is what you can say which is VA, which is positive, which is beta you can say positive here. So this is VA. Now beta current from like this bacha. So VA minus beta this is R minus beta IR minus beta VB, which is equals to 0. That just now beta we proved here. V and B both are 0, 0. So finally you can write beta party E is equals to what? Tell beta party E is equals to IR. Beta what we can say here? Beta, if you are moving from here beta party minus to plus. So any consideration here I can say for that case. Let us suppose we are moving like this na VA positive. Okay, VA positive minus BB positive plus to minus. This is plus to minus minus here. So this is minus and this is plus beta party. Then you can say what E is equals to I by R. So I beta what you can write? This is E upon R. I beta what you can write? E upon R. Right. Beta also we can think beta like for open circuit. Beta G for open circuit. Beta G for open circuit. You can think beta my dear like this. This is beta. Yes, beta. So this is beta point A, this is point B. So this is point A, which you can see point A also. Now, what's about it? So what about beta open circuit here? Current is equals to 0. So you can write beta VA minus VB, which is nothing but is equals to E. VA minus VB, which is nothing but you can say which this is what basically which E. E is what EMF of the cell, right? So beta this is all about beta I said about the basic point. Now which I want to just connect, that is circuit theory. What my dear, I'm going to discuss that is beta next point, which is equals to beta I can say circuit theory, right? This is what is circuit theory. So what is circuit theory? What's that? Circuit theory is what? Circuit theory is a analysis. What my dear? Circuit theory is a linear analysis in which describe the flow of energy around an electrical loop. But again, I'm repeating the student. Circuit theory is a linear analysis in which describe the flow of energy around an electrical loop. What, my dear? Around an electrical loop, right? Okay. So, which you can understand in the easiest way, beta, circuit theory, we have a numerical. Let us suppose, beta, this is what we can take. This is a 5 ohm resistor. Beta. It's literally fundamental numerical beta, right? And this is, you can say 20 volt. So this is 0, this is 0. This is 20 volt, which so you can definitely say, sir, this is also 0, this is also 0. So what is the current over here, which V by R beta. So this is, you can say 4 ampere. I is what beta? You can say this is what basically 4 ampere. Now beta, have a look at next numerical. Beta, you can take, this is 10 volt battery. This is beta, you can take a 5 ohm resistor here. Now beta, you can take, this is 30 volt battery. This is 10 ohm resistor. Beta ji, you can take beta, this is 10 volt. This is 30 volt. Beta, you can say this is 5 ohm and this is what? You can take 10 ohm. What's the question, student? Find current. Beta, find current. Right. Okay. So, bacha ji, for getting current, just beta, I can just replace beta this circuit here. So, let us suppose, this is the big circuit. So, beta, big circuit what will allow to flow of current like this. Big circuit beta flow to allow to what? Flow current like this. Right now, beta, and this is. So, beta, what? Let us suppose if you will start motion from here, beta. So, minus to plus 30 with 70. Plus 30 minus to plus beta. What we can say? Plus only. Beta, what we can say about party? Plus only. So, I can say with party for this condition, beta, what we'll get here? Just beta subtract. Now, this is higher beta, this is lower beta party. 30 minus 3 beta, 20. You can, in solution, beta, so 30 minus 10 here. This is what you can say basically 20. You can say basically 20 here. And between this is what 10 plus 5 here 15. This is 15 by party and this is what 20. So what is I will get? V upon beta R. So I is equals to 4 by 3 ampere. I is equals to what, my dear? 4 by 3 ampere. Okay. Now let's have a look at next question. Yes, beta ji. Have a look at I can say for next question. Beta, go through this here. It's a straightforward party. Question remains simple. Find current in the circuit. You can take this is 10 ohm. This is 10 ohm. This is beta the 100 volt. Find current. It's a beta fundamental numerical layer. Find current with party. So beta what you can write beta for current I is equals to V by R equivalent with in series here. Simply connect beta 100 by 20. So I beta you can write this is what 5 ampere. I student what you can write this is what basically 5 ampere. Okay, beta have we I can say next questions. Yes, beta ji. Uh, Question remains in the find current in the circuit. You can take beta. This is battery. Beta first I'll make circuit with that, then I'll give it the data. This is connecting bar. Yes, fine. But this is what I can say was a connecting wire. Beta, you can take this is 30 volt. This is beta, you can take 10 ampere. This is beta, you can take 5 ohm. 5 ohm, yeah, not ampere. My bad. Sorry. 5 ohm beta. This is 10 ohm. Beta, this is 30. You can take beta. This is what 50 volt. Questions remain same as student. Find current. What would say party? Find current, right? Find flow of current in each wire. Find flow of current beta in each wire. Yeah, it's good. Find student flow of current in beta G each wire. Okay, listen beta carefully. Yeah. It's tough, but we'll go through the party. So, bacha, what you can say? Beta for this wire, what's the current here? Can you find bacha party? This by this? This by beta G, this here. So, what is I bacha? V upon, so V is 30, beta upon 10 here. So, you can say this is what 3 ampere. This is what 3 ampere. Beta simply you can beta find here also. Beta I is what bacha for this circuit here? V by R bacha? You can say what? 50 by 5, which is nothing but you can say bacha party 10 ampere. This is what you can see 10 ampere. So now bacha 10 ampere beta going from here and here. This is 3 bacha party. So how can we decide bacha party entire current here? Entire current bacha party. How can we decide here? Because this is you can say that from here this is what 10 ampere. Beta from here bacha how much here? This is 10 ampere. Oh, so you can say that this is 10 ampere. This is 10 ampere. So there is no current at all. I is what which is 0 beta for connecting wire. I is what which is party 0 beta. What you can say for connecting wire. So beta they can ask here this kind of question. It's not tough, but it's the basic only. Okay. Now beta, do we have one more questions? Yes, beta. This is I can say hard problem. Yes, beta. Hard problem, bacha. So yes, anytime, anywhere, student you can watch physics point. Beta, anytime, anywhere you can watch beta physics point. Yes, beta, this is beta register. Beta, this is the battery. Yes, yes, beta. You can take beta, this is 10 volt. Beta, this is you can take 5 ohm. Beta, this is 5 volt. Yes, beta, this is 10 here. You can see this is what? 2, 8. You can take beta, this is what? Basically 8 ohm. Questions remain same, bacha. Find, find beta J flow of current in each wire. Yes, beta. So again, beta, have a look at solution. So what is solution, my dear? This is beta. You can say 0. So this is beta. What you can say minus to plus here plus. This is plus 10 volt. Now let us suppose it's your choice. Either you can move firstly from this direction or you can move it up firstly from this direction. Now what I'm considering, I'm moving firstly from this direction. So this is what? Plus minus minus to 10 minus 2, 8. 8 upon 8 bacha. So this is what? Current beta you will get for this circuit. 1 ampere. Again I'm repeating bacha. Student. This is 10 volt. This is 2. So plus 2 minus minus. So 10 minus 2, 8. So beta what is current here? V by R. So 8 by 8 beta. 1 ampere you will get. The bacha party 1 ampere. Now beta, this is remains 10 volt here. So this is 10 bacha party plus here. This is what? Plus to minus minus. So 10 minus 5. 5 volt. 5 upon 5 bacha. Oh, beta, this is also bacha 1 ampere. So current beta 1 ampere will come beta from here only. 1 ampere bacha from here only. And here beta how much here? This is 2 ampere. This is what beta is 2 ampere. Right? Okay, so beta, this is answer beta for these questions. Now, beta, I can say they can ask beta multiple questions based on this, and they can frame your multiple questions based on this. But I don't want to waste time much here. I wanted to beta start next questions here, next concept. So this is what my dear, this is what my dear, Kirchhoff's law. Beta, now I'm going to discuss. This is Kirchhoff's KCL. Beta, I can say Kirchhoff's current law. Orbiter, you can see Kirchhoff's beta junction law. What was party? Kirchhoff's junction law. Or beta, I can also say here, Kirchhoff's first law. Kirchhoff's student. Kirchhoff's first law. Now, bacha, this is the condition there. Okay. So, bacha, it's literally highly important for I can say current electricity. So now, bacha, I can say for this condition. No, but it is what? Based on which I can say conservation of Tilvachar party. It is what? Based on beta conservation of charge. Beta keep in mind what's this question. Beta the statement of Coulomb's Kirchhoff's first law beta asked by J multiple time as a theory question. Beta. So what's the question? Kirchhoff's first law based on there are many options: conservation of charge, conservation of momentum, conservation of energy, and all. So, beta, what's your answer? Conservation of charge. Yes, beta. So, let us suppose, beta, I know current going, bacha. Right. This is, you can say I1. Uh, this is what I2. This is what I3. Beta I4. This is what you can say, bacha, party I5. So, beta, simply you can write here. Also, beta, I can say current go inside and outside, bacha. You can say same thing, bacha, party, right? So summation of current which has the inside is equals to which summation of current which has the this is beta outside beta what we can say outside here, right? So with that just keep in mind which party you can think better like na current beta. Let us suppose I wanted to highlight here this point. You can think beta this is beta current I1 going in beta, this is what going out. Beta, this current beta you can say again beta. This is direction going in beta. This is what going out beta. This current is what beta in outward direction. So we are keeping our mind beta party. Summation of current inside is equals to beta. You can say what summation of current beta party goes outside here. Simple. So simple beta you can apply and keep in your mind this concept over here. Right, according to beta principle of conservation of charge at any junction of an electrical circuit, sum of all current, listen beta carefully, sum of all current flowing into the junction must be equal to sum of all current flowing out from junction. That's all, bacha party. So, beta, keep in your mind, bacha party. What's this statement, bacha? The statement of Kirchhoff's first law, beta, according to the principle of conservation of charge or at any junction of an electrical circuit, sum of all the currents flowing into the junction must be equal to the sum of all currents flowing out from the junction. So, beta, this is what you can say, beta, statement of it's a KCL, or you can say Kirchhoff's law number one. This is what, my dear, Kirchhoff's law number one, beta. So, beta, you can keep your mind here. Okay, beta, have a look at example based on this. Beta, have a look, beta. I can say example based on this. Okay, I'll do beta on next page here. Yes. You can take beta. This is some questions like this. Yes, beta. This is the question. Yes, beta. This is the question. Now, beta, as previously as I gave the question here, easily you can find everything. But here, beta, not possible at all. You can take beta random data, anything. This is 10 volt. This is the 5 volt. This is 2 volt. You can say, beta, this is 8 ohm. This is you can take beta 2 ohm. Beta questions remain same. This is 10 volt na beta. So you can say this is 2, right? Beta everywhere 2 here, take 2 beta, 2 ohm only. Everywhere student you can take 2 ohm only so that we can easily beta used like calculate here. So no beta here you can apply beta junction law. Students here you can apply what beta junction law because without junction law you can't do this question beta. So this point student you can treat. But at this point, you can treat as a junction. So let us suppose I'm calling beta g x. Student, I'm calling this point is what x. So beta, you can say x is what at higher potential. Beta junction point beta. Hello, Shamrit Gupta. How are you, my dear? Beta junction point beta always. What you can say beta at a higher potential beta party. So now student, you can say beta for this condition. Current will flow like this. Let us suppose you can take beta you can take deer as a consideration. This is what current beta you can say I1. You can tell my dear this is current is I2. Now you can say beta this is current is I3. This is what my dear current is I3. Now beta just I said here the entire summation of current which is equals to beta 0. So we can write beta but summation of entire current is equals to 0. This is what I1 plus I2 plus I3, which is equals to 0. I haven't got party. Just better go through this here. This is a higher potential got party. You can see, my dear, this is 0, this is 0, this is 0 beta. Okay, so beta I1 is what which I can say x minus 0 upon 2 plus beta z x beta plus 2 minus minus x minus chain upon beta z 2 plus beta z x minus beta 0 x minus beta what you can say 5 here x minus 5 x minus beta is the 5 okay how beta you can take care there is one register yes beta there is what one register with a party you can take beta this is what basically 2 ohm yes beta so x minus 5 upon 2 is equal to 0 beta just take LCM beta party so you can say x plus x plus x 3x 3x is equals to beta 15 here. So x beta what will get? 5. It's a volt beta. Simply beta we can find I1 I2 beta. So let's beta find I1 beta. So I1 is what beta? V. V beta what? You can say 5. 5 upon 2 beta. This is you can say 2.5 ampere. I2 beta is going through this here. So I2 is what beta? This one only. X minus 1 0 upon 2 beta. X beta how much? 5. So 5 minus 10 beta 2 here. So this is what minus 5 by 2, which is equals to minus 2.5 ampere. Okay, beta this is you can see minus beta the 2.5 ampere. Okay, now beta I3 here. No beta this is I have taken direction beta invert means in reality beta I can say current beta minus what implies beta I2 beta you are getting minus 2.5 ampere. What implies here? So you can see beta for this condition, current what beta goes inside here, but I have taken beta in this direction beta. This is beta meaning of beta minus. I3 beta, what you can write? I3 is equals to my dear I3 beta. So this is a beta I can here x minus 5, x minus 5 upon beta 2. X remains 5 here, so 5 minus 5 means beta. You can say there is no value of current in what? I can say 2 ohm register. Student, there is no value of current which what you can say 2 ohm resistor. Okay. Just wait. Have a look here. Next questions. Look at the next question there. So what's the question we can see? There is little changes, beta. Because there is little changes. Beta, this is the last question, beta, for today class. Beta, this is last question beta for today class. Okay. So beta, I can see for this condition. Yes, beta, you take. Beta, first I'll draw beta circuit. Now the student. Then I'll take data. Yes, beta, I can take. Now, beta, there is a battery. Yes, beta. You can take which further here. One more battery over there. One more arrangement is there. You can beta connect here. One more. Timeless no which so I'll just wanted to do just complete the concept with the party. Okay. Then beta. I'll take here all resistances which is equals to 2 ohm. So 2, 2, 2, and 2. Now beta, this is 10, 8, you can take beta 5, 2, 6, and 4. Simple with the party. What's the question, student? Find flow of current. Student, what's the question? Find flow of current in the circuit. Find beta flow of current in the circuit, my dear. Right? This is a question basically. So beta, you can say for this question, beta, dear, you can write beta for this question. Yes, beta. Beta again, beta you can take junction point. Chaji, again, beta you can take what? Junction point. Right, beta? So beta, this point you can take beta something. Let us suppose this point I'm considering with a party x. So this point is what with a x minus. What's the potential difference? Plus to beta minus minus here. This is even higher potential. So here beta what you can say? X minus 5. Here beta what you can say? X minus 5. Right, beta? Okay. Then beta see further. Just beta go through this here. Apply beta concept. Johnson law. Beta in solution. Beta you can say according to Johnson law. Beta summation of current which is equals to 0. What might be summation of current which is equals to 0. So beta just yeah. Beta just equate beta entire current. So then you can write this current is what beta I1. This current is what I2. This current is what I3. This current is what I4. I1, I2, I3, and beta what we can say I4. Right, my dear? Okay. And this is a current which further will divide beta in these all parts. So beta first I'll write beta from here. So this is what, my dear? X minus 0 by 2 plus beta z x minus 2 plus here. Just keep in mind x plus 8 by 2. Here what's x minus 10. Student x minus 10 by 2. That's what's about x minus 5. X beta this is in here coming from here. So x minus 5 beta here. So here is what? Plus to minus minus. So x minus 7. X minus 7 by 2. Here what's x beta there is no register here. You can take beta register here. You can take beta register here. This is remains 2 ohm. So you can say what's x minus 7. X minus 7 by 2 which but in this one x minus 6 minus 5 11. You can say plus x minus 11 x minus 11 by 2 plus which property you can say x minus 4 by no 4 plus 5 beta 9 here x minus 9 by 2 is equals to 0 is equals to beta what you can say 0 beta 2 entire cancel here so we can say this is x minus 0 plus x plus 8 plus beta x minus 10 plus x minus 7 plus beta x minus 11 plus x minus 9 is equals to 0 beta party. Simply beta I can do 1, 2, 3, 4, 1, 2, 3, 4, 5, 6x. Beta is 6x. Beta is minus. Beta you can say 17 beta, 17 beta and 9 minus 1 beta minus 18. Minus beta you can say 18 is equals to 0 beta. X beta you will get 3. Beta this value x beta I can feed everywhere beta. You will get I1, I2, I3 and beta following things which you wanted. So till now beta just I finished KCL. What was the party? KCL and basics of current and electricity. Beta, tomorrow class, beta, I'll try to just continue from here onwards. Now, students, I'm going to stop live session. All the very best, everyone.